Okay, so hello and welcome back. So the next formulas that we need to derive here are basically tan of x plus y, tan of x minus y. So basically we said that to calculate tan of x plus y, to calculate tan of x plus y, basically you know that tan of x plus y is the same thing as sine of x plus y over cos of x plus y. So you know that basically sine of x plus y is equal to sine x cos y plus cos x sine y, and cos of x plus y is equal to cos x cos y minus sine x sine y, right? Minus sine x sine y. Now if you divide the denominator by cos x cos y, dividing the numerator and denominator by cos x cos y, we have, so this becomes basically sine x cos y divided by cos x cos y divided by cos x cos y, and then you have here cos x sine y, and divide that by cos x cos y, and then over here you have cos x cos y, and divide that by cos x cos y, and minus sine x sine y, divide that by cos x cos y. So over here cos y and cos y will cancel out, cos x and cos x will cancel out, so cos x and cos x, cos y and cos y will cancel out. So you have basically sin x by cos x is equal to tan x, and sin y by cos y is equal to tan y. And here you have 1 minus basically sin x by cos x is equal to tan x, and sin y by cos y is equal to tan y, right? So that means that basically tan of x plus y is equal to tan x plus tan y over 1 minus tan x tan y over 1 minus tan x tan y. That is the formula for tan of x plus y. Now if you in this formula, if you replace y with negative y, with negative y, we have basically tan of x minus y is equal to tan x plus tan of negative y, and you have 1 minus tan x tan of negative y. So tan of negative y is equal to negative tan y. Tan of negative y is equal to negative tan y, and therefore this is equal to tan x minus tan y, and this is equal to 1 plus tan x tan y. So tan of negative y basically becomes negative tan y. Negative into negative is positive, so tan x tan y. So that is basically tan of x minus y. Right? So that is that. Now, of course, here you need to of course here basically x plus y, the limitation on this formula is that x and y and basically x plus y are not an odd multiple of pi by 2, are not an odd multiple of pi by 2, because at odd multiples of pi by 2, meaning at pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, or at negative pi by 2, and so on and so forth, the basically tan of x is not defined, and therefore the xy and x plus y are not supposed to be any of those angles. And the same thing, of course, applies here to this formula. So now basically then you can, in the same way, you can calculate cot of x plus y and cot of x minus y. So basically cot of x plus y is equal to cos of x plus y, cos of x plus y over sine of x plus y. Now cos of x plus y is equal to cos x cos y minus sine x sine y, and sine of x plus y is equal to sine x cos y plus cos x sine y, right? Now if I divide the numerator and denominator by sine x sine y, divide the numerator and denominator by sine x sine y, we have so this becomes basically cos x cos y, cos x cos y over over sine x sine y, minus, then you have sine x sine y over sine x sine y, and then you have over here sine x cos y, sine x cos y over sine x sine y over sine x sine y, and over here you have cos x sine y, cos x sine y over sine x sine y. So cos x by sine x is equal to cot x, and cos y by x sine y is equal to cot y. And over here basically these will cancel out, over here these will cancel out, and sine y and sine y will cancel out. So what you will get is basically, this is cot x cot y, This is cot x, cot y, and this is a 1. And over here you have cot y by sine y, which is equal to cot y plus cos x by sine x is equal to cot x. So, and therefore you can write basically cot of x plus y. Cot of x plus y is equal to cot x cot y plus 1 is equal to cot x cot y plus 1 over cot y plus cot x over cot y plus cot x. And over here, of course, you know that cot y is not basically the cot function is not defined whenever, so you know that basically cot of x is equal to cos of x by sine of x. So whenever sine of x is equal to 0, then cot of x is not defined, which means that basically at 0 and pi and all the multiples of pi, basically this formula would not work. So that means that, so then you can say that cot of x plus y is equal to this, provided that x, y, and x plus y are not integral multiples of pi. Are not integral multiples of pi. Now, if in this formula, what you can do is that you can replace basically y with negative y, and you will get basically cot of x minus y is equal to cot x cot y, cot of negative y plus 1, and then over here you can write cot of negative y. You can write cot of negative y plus cot of x. Now you know that cot of negative y is equal to negative cot y, which means that you can write basically cot x and cot y, and you have a negative sign that is multiplied here, plus 1, and that is negative cot y plus cot x, right? So then what you will get is, and then of course you can basically multiply both the numerator and denominator by a factor of negative 1, meaning that if you multiply numerator and denominator by negative 1, you will have basically, so you will get one basically you will have basically cot x cot y minus 1 over cot y minus cot x, right? Cot y minus cot x, and that is equal to cot of x minus y. That is equal to cot of x minus y. And here again you need to, of course, pay attention to the fact that that x, y, and x minus y are not integral multiples of pi. Otherwise the formula does not work. So that is basically that. Now, another formula that we can derive here is basically three different forms of cos of 2x. So cos of 2x is basically equal to cos squared x minus sine squared x. Cos squared x minus sine squared x. It's also equal to 2 cos squared x minus 1 is equal to 2 cos squared x minus 1. It's also equal to 1 minus 2 times sine squared x. And it is also equal to 1 minus tan squared x over 1 plus tan squared x. So these are the four different forms of cos 2x that, well, not all the possible forms, but the four forms that are extensively used in this text basically. Okay, so now in order to prove these, the first one, so basically you know that cos of x plus y is equal to cos x cos y minus sin x sin y. And so if I basically substitute basically y with x, we have, so if you substitute y with x, we have basically cos of x plus x is equal to cos x minus sin x sin x. And so cos of 2x is equal to cos squared x minus sin squared x. Right? So cos of 2x is equal to cos squared x minus sin squared x. That is this first one over here. This first one over here that we wanted to prove. The second one, of course, you know that cos squared x plus sin squared x is equal to 1. That means that cos squared x is equal to 1 minus sin squared x, and sin squared x is equal to 1 minus cos squared x. So in this formula, if I write cos of 2x is equal to, instead of cos squared x, if I write 1 minus sin squared x, and over here again I have minus sin squared x. So then I have 1 minus 2 times sin squared x. And that is cos of 2x. So cos of 2x is 1 minus 2 times sin squared x, which is this one over here. Now again, in this formula, what I can do is that instead of cos squared x, instead of basically sin squared x, I can write 1 minus cos squared x, meaning that I can write cos of 2x is equal to cos squared x minus sin squared x is equal to 1 minus cos squared x. 1 minus cos squared x, which is equal to cos squared x is minus 1 plus cos squared x Okay, plus cos squared x, which is the same thing as 2 cos squared x minus 1. And so that is cos of 2x. 2 cos squared x minus 1. So that is this one over here. And also, basically, cos of 2x, you can write it as cos squared x by, okay, so if you write to prove this one, 1 minus tan squared x over 1 plus tan squared x, to prove this one, you have basically cos of 2x. Cos of 2x, we said that it's equal to cos squared x plus, we said that it's equal to cos squared x minus sin squared x. We already proved this somewhere over here. Cos squared x minus sin squared x, right? So cos squared x minus sin squared x. Now you know that basically I wrote something over here which was not exactly very relevant here. So you know that basically sin squared x plus cos squared x is equal to 1, right? So I can divide this by 1 and nothing will change in the fraction. So I can write this as cos squared x minus sin squared x and write it as cos squared x plus sin squared x, right? And then here basically if I divide the numerator and denominator by cos squared x, if I divide the numerator and denominator by cos squared x, we have basically cos squared x by cos squared x minus sin squared x by cos squared x over cos squared x by cos squared x plus sin squared x by cos squared x. Now this will be 1 and this will be again 1. So you have basically 1 minus sin squared x by cos squared x is equal to tan squared x. So 1 minus tan squared x. And over here you have 1 plus sin squared x by cos squared x is equal to tan squared x. So which means that cos of 2x is equal to 1 minus tan squared x over 1 plus tan squared x over 1 plus tan squared x, right? So that is basically that. And here the condition that we have on this formula is that x is not equal to n pi plus pi by 2, where n is an integer and belonging to the set of integers. So what that means is that, for example, of course x cannot be basically a multiple of pi by 2 and also a multiple of pi, a multiple of pi by 2 and also a multiple, but cos has no problem we have no problem in the domain of x. But but basically in the domain of tan we have a problem, and this is a little bit odd, meaning that if basically suppose that n is equal to 0, then n pi plus pi by 2 is equal to pi by 2. That makes sense. If n is equal to 1, then n pi plus pi by 2 is equal to pi plus pi by 2, which is equal to 2 pi plus pi, which is equal to 3 pi by 2. That makes sense. If n is equal to 2, then n pi plus pi by 2 is equal to 2 pi plus pi by 2, which is equal to basically 2 pi plus pi by 2 is equal to I think 5 pi by 2, right? Because you have 2 over here, and that is 4 pi plus pi, so that is 5 pi by 2. Now these are all the multiples of pi by 2, and then if n is equal to -1, for example, then n pi plus pi by 2 is equal to -pi plus pi by 2. So -pi plus pi by 2, you will end up at 3 pi by 2, I suppose, right? You will end up at 3, or the -3 pi by 2. Let me see. So you have basically -2 times pi plus pi, which is equal to -pi by 2. And if for example, if n is equal to -2, then n pi plus pi by 2 is equal to -2 pi plus pi by 2, which is equal to -4 pi plus pi, which is equal to -3 pi by 2. So -2 pi, so -2 pi plus pi by 2 is equal to -3 pi by 2, meaning that if I am at -2 pi, so -2 pi is basically going in this direction on the circle, and again ending up over here. That's -2 pi. Now -2 pi plus pi by 2 you will end up at -3 pi by 2 right here. So that is basically taking out all the multiples of all the integral multiples of pi by 2 from this formula. So that's something that you can use. I wasn't actually familiar with this form of the multiple. These can be extensively used when you're doing something. You can write this as x not equal to n pi plus pi by 2, where n belongs to a set of integers, right? Normally you write this as x not equal to 2n plus 1 times pi by 2, where n belongs to integers. That gives you again the same result. But it seems that you can write it this way as well, right? Okay. Now, so these were all the different forms of basically cos of 2x. Cos of 2x is equal to cos squared x minus sin squared x. It's equal to 2 cos squared x minus 1. It's equal to 1 minus 2 sin squared x and 1 minus tan squared x over 1 plus tan squared x. So the next thing that we have is the next thing that we have is sine of 2x. Is sine of 2x. Now sine of 2x is equal to 2 times sin x cos x. 2 times sin x cos x. It's also equal to 2 tan x it's also equal to 2 times tan x over 1 plus tan squared x over 1 plus tan squared x. And here again, basically, here again, x is not equal to n pi plus pi by 2, where n belongs to the set of integers. So we will basically prove this as well. Okay, so the next thing that we have here is basically sine of 2x, which is equal to 2 sine x cos x, and this other form over here. Now, of course, as you can imagine, calculating sine of 2x must be easy, because sine of 2, basically, we know that the sine of x plus y is equal to sine x cos y plus cos x sine y, which means that instead of, if I substitute basically y with x, we have basically sine of x plus x is equal to sine x cos x plus cos x sine x, which is the same thing as, this is sine x cos x, this is sine x cos x, which is the same thing as 2 times sine x cos x. So that means that sine of 2x is equal to 2 times sine x cos x. That is the first result here. Moreover, you can, I think we can divide this by, if basically in this, basically if you divide the right hand side, dividing the right hand side RHS by sine squared x plus cos squared x, we have, and of course you know that this is equal to 1, so I have the sine of 2x is equal to 2 times sine x cos x over sine squared x plus cos squared x, right? And then if I divide both sides of basically the numerator and denominator here by cos x, dividing the numerator and denominator by cos x, so over here we get 2 tan x by cos x. Let's see what we get by cos x. We have sine of 2x is equal to 2 times sine x cos x over basically over cos x. Actually, it has to be cos squared x. It has to be cos squared x. By cos squared x, so you have sine squared x by cos squared x plus cos squared x by cos squared x. And then you will have cos x here, and this they will be cancelled out. You will have a 1 over here, and so then this is equal to basically sin x by cos x is equal to tan x, so that's 2 times tan x over, then this is equal to basically 1 plus tan squared x. So this is sin squared by cos squared is tan squared, so that is 1 plus tan squared x, which means that which means that sine of 2x is equal to 2 times tan x over 1 plus tan squared x. And here we need to make we need to mention that x is not equal to n pi plus pi by 2, where n belongs to the set of integers, right? So that is basically basically 2 tan x 1 plus tan squared x. Okay. Now the next formula that we have is basically the formula for tan of 2x. For tan of 2x, and tan of 2x is equal to 2 times tan x, 2 times tan x over 1 minus tan squared x, 1 minus tan squared x. And 2x is not supposed to be equal to n pi plus pi by 2. 2n is not supposed to be equal to n pi plus pi by 2, where n belongs to the set of integers, because tan is not, basically tan is, the tan function is not defined for the multiples of pi by 2, the odd multiples of pi by 2. So what that means is that now tan of, the tan of x plus y, we said that tan of x plus y is equal to tan x plus tan y is equal to tan x plus tan y, and you divide that by 1 minus tan x tan y. 1 minus tan x tan y, right? So tan of x plus y is equal to tan x plus tan y, 1 minus tan x tan y. Now if I of course, since I'm calculating tan of 2x, if I replace y with x here, we have tan of x plus x is equal to tan x plus tan x, and 1 minus tan x tan x, which is the same thing as 2 times tan x and 1 minus tan squared x, 1 minus tan squared x, and that is tan of x plus x, which is equal to 2x. So tan of 2x is equal to 2 times tan x, 1 minus tan squared x, and here we need to make the distinction that 2x is not supposed to be equal to n pi plus pi by 2, where n belongs to the set of integers. And of course, you know that also x has to have the same condition, but I think if 2x is not equal to this, is not equal to the odd multiples of pi by 2, then if you work through this condition, you will have the conclusion that this condition implies that also x is not equal to the odd multiples of pi by 2. You need to basically do that if you want to find out. But even if that's not the case, then you can of course say that x also is not equal to n pi plus pi by 2, where n belongs to the set of integers. But I think this is actually implied by this upper equation here. Okay, so that was tan of 2x. Now, if you have, let's say that we want to calculate sine of 3x. We want to calculate sine of 3x. So I can write the sine of 3x, and that is actually equal to 3 times sine x. 3 times sine x minus 4 times sine cube x. Okay. Now, you can write sine of 3x as basically sine of 2x plus x, right? And you know that basically sine of x plus y is equal to sine x cos y plus cos x sine y. Sine of x plus y is equal to sine x cos y plus cos x sine y. So I can write this as basically sine 2x cos x plus cos 2x sine x, right? Now, basically you already know that sine of 2x is equal to, we said that sine of 2x is, the sine of 2x is equal to, we said that it's equal to 2 times sine x cos x, and it's also equal to 2 tan x over, it's equal to 2 tan x over 1 plus tan squared x. 1 plus tan squared x, that is sine of 2x. And also cos of 2x, we said that it is basically cos squared x minus sine squared x, cos squared x minus sine squared x. It's also equal to 2 cos squared x minus 1, 2 cos squared x minus 1. It's also equal to 1 minus 2 times sine squared x. And it's also equal to 1 minus tan squared x over 1 plus tan squared x. Right, so that is cos of 2x. So that is that. Now, using the information that we have here, I can rewrite this as sine of 2x. I can write it as 2 times sine x cos x, 2 times sine x cos x times cos x. Cos of 2x, I can write it as basically 1 minus 2 times sine squared x, 1 minus 2 times sine squared x, and multiply that by sine x. Then you have basically, if you simplify this, you will get 2 times sine x cos squared x plus sine x minus sine x minus 2 times sine cube x, right? So from all of these, I think I can take a sine out. Let me see what they have done here. Okay, so what they have done is that they have written this cos squared x as 1 minus sine squared x, because you know that basically sine squared x plus cos squared x is equal to 1, which means that you can write, cos squared x is equal to 1 minus sine squared x. 1 minus sine squared x. So I can write this as basically 2 times sine x times basically 1 minus sine squared x plus sine x minus 2 times sine cube x, right? And And so let me simplify this. So I have basically, if I multiply this, I get 2 times sine x minus 2 times sine cube x minus 2 times sine cube x plus sine x minus 2 times sine cube x. So 2 times sine x plus sine x is equal to 3 times sine x, and minus 2 times sine cube x minus 2 times sine cube x is equal to minus 4 times sine cube x. And that's basically what we have here. So you can say that sine of 3x is equal to 3 times sine x minus 4 times sine cube x. That is sine of 3x. Right? That is that. Now, the next thing that we have here is cos of 3x is equal to cos of 3x, which is equal to 4 times cos cube x, 4 times cos cube x minus 3 times cos x. Right, so that is basically that. Now, so you can write basically to prove this, you can say that the cos of 3x is equal to cos of 2x plus x, right? Cos of 2x plus x. Now, you know that basically cos of x plus y is equal to cos x cos y minus sin x sin y. Minus sin x sin y. So I can write this as basically cos 2x times cos x minus sin 2x times sin x times sin x. Now here we said that cos 2x is equal to, here we said that cos 2x is equal to 2 cos squared x minus 1. So cos 2x, I can write it as 2 cos squared x minus 1 times cos x. Sin 2x is equal to 2 times sin 2x is equal to 2 times sin x cos x, is equal to 2 times sin x cos x times sin x. So if I simplify this, I'll get 2 times cos cube x minus cos x minus 2 times sin squared x cos x. Now I can take the cos x out of these two, meaning that I can write 2 times cos cube x, and basically you know that basically 1 minus 2, let me see, 1 minus 2 times sin squared x, right, is equal to cos 2x. No. I'm not going to be concerned about the 2. I'm not going to be concerned about the 2, but somehow you need to simplify this. So we have written this as basically 2 cos squared x minus 1 times cos x minus 2 times sin x cos x sin x. That is, here we have no problem. And then let me erase all of these. And then what you need to do is that basically sine squared x, you see that over here, so I'm not going to touch this part at all, so I'm going to write it as 2 times cos squared x minus 1 times cos x, and then over here I have negative 2 times sine squared x cos x, right? Now sine squared x is equal to 1 minus cos squared x. You already know this. So I write this as 2 times cos squared x minus 1 times cos x, and then negative 2 times cos x times sine squared x is equal to 1 minus cos squared x, right? And then I can multiply now, meaning that I can write this here as 2 times cos cube x, 2 times cos cube x minus cos x, and over here I have minus 2 times cos x plus 2 times cos cube x. So you have 4 times, you have basically 2 times cos cube x, 2 times cos cube x is equal to 4 times cos cube x, 4 times cos cube x, negative 2 times cos x, negative cos x is negative 3 times cos x. And therefore you can say that cos of 3x is equal to 4 times cos cube x minus 3 times cos x. That is the formula that we wanted to show here. Now there is one more such formulas here that we will do this, and then we will basically summarize the whole thing. So we want to calculate tan of 3x. So tan of 3x happens to be 3 times tan x, happens to be 3 times tan x minus tan cube of x, 1 minus 3 times tan squared x. And of course here basically if 3x is not equal to n pi plus pi by 2, where n belongs to the set of integers, right? Now in order to prove this, you can say tan of 3x is equal to tan of 2x plus x. Okay, so now we know that basically we said that tan of x plus y, we said that tan of x plus y is equal to basically, if I'm not mistaken, what is tan of x plus y? Tan of x plus y is equal to tan x plus tan y, tan x plus tan y, and 1 minus tan x tan y, right? 1 minus tan x tan y. That is basically what we know from before. So which means that basically tan of 2x plus x, I can write it as tan of 2x, tan 2x plus tan x over 1 minus tan 2x tan x, right? And then what we can do here, and we know that tan of 2x was equal to 2 tan x 1 minus over 1 minus tan squared x. So we said that tan of 2x is equal to 2 times tan x 1 minus tan squared x. So I can write this as basically tan of 2x, I can write it as 2 times tan x, 2 times tan x, 1 minus tan squared x. And then I can write, I have over here plus tan x, and 1 minus, and you have tan of 2x, which is again the same thing here. So you have 2 times tan x over 1 minus tan squared x, and you need to basically multiply tan of x here as well, times tan x. Right? So that is basically what we have. Now what we can do is that we can first add all of these together, I suppose. So we need to simplify a little bit, meaning that I can write this as take the LCM as 1 minus tan squared x, and over here I have 2 times tan x plus tan x times 1 minus tan squared x. Right, so that is that. And then I have, in the denominator, I have 1 minus tan squared x. And over here, 1 times 1 minus tan squared x, 1 minus tan squared x, minus this thing over here, which is 2 tan squared x. So then I can simplify these two, and I can write this as 2 times tan x plus, or this is tan x minus tan cube x plus tan x minus tan cube x, and then I can write the denominator as minus tan squared minus 2 tan squared is 1 minus 3 times tan squared x, right? And then 2 tan x plus tan x is equal to 3 tan x minus tan cube x over 1 minus 3 times tan squared x. Which seems to be what we were looking for, right? So we said that basically tan of 3x is 3 tan x minus tan cube x over 1 minus 3 times tan squared x. So that means that tan of 3x is equal to 3 times tan x minus tan cube x over 1 minus 3 times tan squared x. And of course you know that the condition that we have here is that 3x is not supposed to be equal to n pi plus pi divided by 2 for n belonging to the set of integers. And so that brings us to almost the end of these formulas. There is of course a couple more formulas that we need to derive in the next video. But then now what we need to do is just summarize these formulas and then basically get to the rest of the formula. So I'm going to put this over here and then open some paint here so that we can write something here. And so from the very beginning, we said that I do not really know. Okay, so we did the summary of all of those formulas related to half angles and pi by 2 and 3 pi by 2 and so on and so forth. Now, the rest of the formulas that we have not done a summary of, is basically tan of x plus y. So basically we had tan of x plus y is equal to basically tan x plus tan y is equal to tan x plus tan y over 1 minus tan x tan y over 1 minus tan x tan y, right? And this is provided that, of course, provided that xy and x plus y are not equal to an odd multiple of my pi by 2, meaning that is not equal to n times pi plus pi by 2 for n belonging to the set of integers, right? The next formula that we had was that tan of x minus y was tan of x minus y, which we said was equal to tan x minus tan y, tan x minus tan y over 1 plus tan x tan y over 1 plus tan x tan y. And that is basically, again, provided that xy and again the same condition, xy and x minus y is not equal to n pi plus pi divided by 2 for all n belonging to the set of integers. Now, if we have if basically the cot of x plus y, we said that the cot of x plus y is equal to cot x cot y is equal to cot x cot y minus 1 over cot y plus cot x, cot y plus cot x. And that is provided that, of course, xy and x minus x plus y, xy and x plus y are not equal to any multiple of pi, because at x is equal to pi, for example, then the cos of x is equal to 0, then cot is not defined. It's not equal to n times pi for all n belonging to the set of integers. And also we had cot of x minus y, which was equal to basically cot x cot y plus 1 over cot y plus cot x cot y minus cot x, and that is again provided that x and y and x minus y are not equal to n times pi, where n belongs to the set of integers. The next formulas that we had were let me make a screenshot here. So I'm going to call this, for example, trigonometric part. No, let's call it part 3. Save it there. And then I'm going to need to make a new, no, not this. How do you make new? Well, it's certainly not. Okay, don't save. Right. Now, The next thing that we have is basically cos of 2x, we have sine of 2x, we have so let me actually write on the, I'm not really very fond of this software. Actually, let me write over here, because otherwise, okay. So 62, and so the next thing that we have here is basically we have sine of 2x, we have cos of 2x, sine of 2x. So we have a couple more things here to summarize. We have cos of 2x, we have sine of 2x, we have tan of 2x, we have tan of 2x, then we have sine 3x, cos 3x, tan 3x, then we have sine 3x, cos 3x, and tan 3x. Then we have, and that is it basically. So let's start with these three. So we said that basically sine 2x, we said that sine 2x is equal to we said that sine 2x is equal to 2 times sine x cos x, 2 times sine x cos x, and it is also equal to basically 2 times tan x over 1 plus tan squared x for all x not belonging to, of course this is again, x is not supposed to be equal to pi by 2 or any odd multiple of that. So for all x not equal to n times pi plus pi by 2, where n belongs to a set of integers, and that is basically sine of 2x. Now cos of 2x is equal to, there is a whole lot of formulas for cos of 2x. We said that cos of 2x is equal to cos squared x minus sine squared x. It is also equal to 2 cos squared x minus 1. It is also equal to 1 minus 2 times sine squared x. And it is also equal to 1 minus tan squared x over 1 plus tan squared x. 1 plus tan squared x. And of course here you know that x is not supposed to be any odd multiple of pi by 2, but otherwise over here we have no restriction for sine and cos. The domain of these functions are pretty much anything that you want to. It's a set of real numbers really. So that is for sine and cos of 2x. Now for tan of 2x, so let me actually do a little bit of so for tan of 2x, we had 2 times tan x over 1 minus tan squared x. 1 minus tan squared x, and well here basically 2x is not supposed to be equal to n times pi plus pi by 2, where n belongs to a set of integers. And that's basically for sine of 2x. That is basically for sine of 2x, cos of 2x, and tan of 2x, right? So I will make another screenshot here, because we are going to need this in elsewhere in other courses and so on and so forth. And I'm going to call this trigonometric ratios part 4, for example, and save it there. And now we are going to do basically sine, cos, and tan of 4x. 4x it was? No, 3x, I'm sorry. 3x, what was that? What was we doing right here? 2x, so 3x. So, let me see. Okay, so the next formulas that we had were basically sine of 3x is equal to 3 times sine x, 3 times sine x minus 4 times sine cube x. And we said that basically cos of 3x is equal to 4 times cos cube x, 4 times cos cube x minus 3 times cos x. And we said that tan of 3x is equal to basically 3 tan x minus tan cube x over 1 minus 3 times tan squared x. And of course here we need to note that basically 3x is not equal to n pi plus pi by 2, where n belongs to the set of integers, right? So that's basically all the formulas that we had so far. And in the next video we will derive a couple more formulas. So I'll see you in the next video. Thank you.